Okay. My goal today is trying to finish the um, the template and the function pointer. This was where we were. And also I start to talk about threads. So my plan is to cover during the lecture for the GPU programming related stuff for this and next week. But in the evening, we'll work on the project, okay, and the grading for the homework as well. Pretty much every evening, I will be here, except this week, for example, Thursday evening. Okay, let me try to finish the function pointer very quickly. So this is where we were last week. The top line is a typical declaration about a function signature, which is talk about, in this line, we'll talk about the first line. The first line is talk about I declare a function, and this function is called function X. And the return type is T return and also have a list argument. So this is just a pure declaration that I will or I have a function. And typically, by the way, the first line is very commonly used. You have to do this, especially when you want to link the function from the other program or the other library. So as we talked about earlier, the concept of a separate compilation, that you would have compiled function X somewhere else. And this line is just declare that for the linker to link this particular function during the linking process. Sometimes things get even more interesting when you have this idea called dynamic linking library. So I never have a chance to talk about this linking business, but linking is something which is quite interesting, is that most of the linking that you're using today, probably at least as a beginner, is what we call static linking. That means you first compile the other library and you try to link to that. But there is also another way of linking that's supported by the modern system. It's called dynamic linking library. Dynamic linking library means that I had this line, the first line, I'm linking to a function, but that function may change when you change the library. Dynamic means that you can actually update your library. For example, you have a function and then you realize that function has a new feature. You want to add it to that. And you don't have to recompile everything. You don't have to relink everything, but just when you do dynamic linking library, it will link to that when you have a new library that's become available. So that become interesting as we make things more adaptive to the new changes. And the second line is also a declaration of function, but the difference between the second line and the third line is the position of the parentheses. You see that in the second line, the parenthesis is putting the star associated explicitly with the T return, the return data type, such that this declare when you return something is going to return, the return type is going to be pointer to this type T return. But if you declare the third way, that's the way we do what we call pointer to function, is that you declare fun X. By the way, the difference between the third line and the first line is that the first line is essentially declare a function called function X. But the third line is declare a type called pointer type. And what kind of type is fun X? It is a pointer that's actually going to be a variable with the type of a pointer to a will return T return and then get the variable. So essentially, func X is a assignable variable. So assignable variable means that this variable you can change its value. That's very it's a very significant. For the first one, the function x is declaration, but itself, you cannot reassign. Okay, you cannot change the value of function x, or in the second line, func x. But in the third line, you essentially declare a variable, and this variable type is a pointer to a function. And because it's a variable, it can be on the left-hand side of assignment operator, which means that you can change the value. So let me show you a program. By the way, the best way to learn is go to CPP 15 to check the value. Let me actually pull it out. I have so many, not so many, but a bunch of programs here. Let me see which one. Let me use the first one, FPTR. This is an example. Yeah, I'm not sure if this is a good example. Okay, that's fine. I'm using function template together with a function pointer. So you can see this part of the code. This is a function template. Okay, this is, as we talked about last week, this is a template to declare a function that's parameterized. The function name is called is in range, but then there is a type T that you can parameterize, and there is a two variable called upper and lower that you can change, and such that you have a what we call a template for us to configure. You can have a bunch of functions that sharing the same structure is in range. Okay, so this is just a function template, and we will use that function template a bit later in this example. Okay, but now this line is what I talk about the third line in the slide. If you look at this, remember what we did in the third slide. Let me pull it out here. You can see that this is the syntax. You have a T return. What's the return type? And then you have a parenthesis with a star fun X. And then you have a list of argument. So let me remember the three things: return type, the star to a function name or function pointer, and then you have a list of argument. Let me actually correspond to this three thing. So in this thing, let me tell you, the bool is the T return. And I will just put the whole thing together. Func PTR is correspond to, in the example, I think I call it FUNC, is that right? Something like that. And then double is, what did I call the third? Whatever. It's called list of T argument, but it's just have a one type. Okay, this just have a one argument. So this is T argument one. Okay, I only have a one. So this line is correspond to the slide I just showed you with this three different elements. So by doing this, I want to say this is a little bit different from the regular. Number one, I would say func PTR is a variable. And this variable data type is a pointer to a particular type of function. I should say not a function, a type of function. And what's that type of function is declared by T return and T argument. Okay, so it's a function that func PTR can use for as a variable name for all kind of function as the pointer type. Okay, so you can actually print out at this moment. My guess is that if you print, say, well, if it's a pointer, of course you can print it. If you print it, I guess at this moment you will see a 0x00000000. Why is that? Because you haven't, it's a variable, but you haven't assigned any real function to that. That's why it's going to be 0000. Okay, so now I can combine these two concepts with the template with the function. So you look at this line, it's interesting. This part is a function template. I'm actually going to create a function which return, sorry, the T argument type is going to be double, and the range is going to be 500 and 0. If you declare it this way, then this function signature should be identical to this one because they both return Boolean. And now the argument type is double. So if you get it, if you see this carefully, that this part of the line I highlighted is consistent with the declaration about that function pointer. Okay, after I create this, I'm going to create a function instance from that template. So this is what I call an instantiation of a function template. From the template, I actually make a new function. And then you can see that I assign that function I just created using template and assign to that function pointer. Okay, so this you see why I said func PTR is important to be assignable. Because it's a variable, it can be assigned. Okay, so after done this line, sorry, and then I repeat the first line again. And this line, I'm actually going to print the pointer. And then this time, you will see the pointer is somewhat different. It must be something which is different. Okay, so let's just run the program, see what happened. G++ minus std is equal to C++ 14 fptr dot cpp, and let me make an fptr dot whatever bin. Okay, so I compile. Now I do fptr dot bin. Okay. Oh, wait a minute. That's interesting. So like even the first line has already been something. So that's interesting. Why? Let me actually check. But I thought the first line is going to be null, but apparently I was wrong. Let me actually do this. Can I do this? Can I do func ptr is equal to null? Can I do this? Okay, so I can assign, I can change the value, but have you noticed no matter how many times I run the program, the second line, which is represent the address to that function, and it is a pointer, and then I actually can run that code. Okay. Okay, so let me actually play a little bit trick. So essentially, this address, oh, wait a minute, the address is different. Sorry about that. The address is different. I thought it's the same, but this one is the B190, but here is 102 B190. So the address, it did change. Every time you instantiate a template, it might assign a different address. Okay, so the first line is just a variable, but the second line is assign that template. And then I'm using that template to call the function, and it's in print out. It is true. Okay. By the way, I should let me see. Do I have the other? Let me actually take a look what I have with my other program. There is one thing I want to talk about. PTR LE. No, it's not here. LE2. Okay, no, it's not here. Okay, so now I can do something. Okay, so let me go back to this code. So I said this is a variable. This is a variable called funcPTR. But I want to create a type. There is another way. Is that okay? My question is, can we have a data type for function pointer? Okay, so I'm going to try to create a data type that's actually represent similar to this particular line, defining a function pointer. So I'm going to use type define. Okay, I might make a few mistakes before I get it right, okay, because I forgot exactly how I did this. So I'm going to do this part, type define, but I'm going to get rid of this. And then I'm going to do the type, the data type. I call it, let's go call this type called bool double FUNC PTR type. Okay, I kind of called a very long name. So see, I want to first check whether this is compilable. Okay, I haven't done this for a while. I'm always suspicious about my own capability. Oh, I cannot do that. I cannot do that. That's interesting. Okay, fine. I know this will happen. Okay, let me try to do, should I do it this way? Let me see. Let me check again. No, I cannot do that. That's interesting. Okay, fine. Can I do this? Type define. Let me do this way. Oh, wait a minute. No, I cannot do this. Let me do a quick Google. Type define pointer to function. So this is the way, how do I type def? Let me check example. Yeah, I thought this is what I did. Oh, I see, I see. I make a mistake. Okay, I know what mistake I made. Okay, sorry. Thank you. Whatever the online resources. What I should do is this. I should do, yes. I should say bool double func ptr type, and I can get rid of this. And then I have to add the star here. So essentially, you can see that now it makes sense. This line is almost identical to this line, except I use type define. I make the type for such a variable is called bool double func ptr type. Okay, now I think I can compile. Yeah, now I have no problem. Okay, now I'm going to play a trick. So instead of doing this, I'm going to get rid of this, and then I can say bool double func ptr type. Remember the way I did it is I make it a data type, and then I say func ptr. I declare a variable based on this type. So this particular line is equivalent to the above two line. It depends on which way you like. Okay, equivalent. Equivalent. I must have a misspell. I don't care right now. Okay, so Emacs doesn't help me to correct my spelling. Okay, and if I run the program, the result should be identical. Okay, you see that I'm actually getting the same result. Okay, so let me actually just summarize what I did with this program. I can declare, either I directly declare a function pointer, looks like this. I declare a function pointer and with this notation, or I declare a type def for this data type that's actually going to represent a function pointer, and then do it this way. Okay, but these two are identical in terms of management or manipulation about pointer to function. I slightly, let me just be honest with you, I slightly prefer this approach than this approach. Okay, they're equivalent. Let me actually tell you that why. Let me explain to you why I like this approach better. Because this approach, if I declare this approach, I declare this way, for me, it's harder for me to understand what I was doing there. Okay, unless you're very careful, you actually look at the parentheses with the star and look at exactly this way, then you know that, oh, wait a minute, here you declare a variable, which is a function pointer. But over here, if I just declare a type define once, looks like this, and I declare a line looks like this, then this is a clear that funcPTR is a variable of the type bool double func pointer type. Okay, so of course, my choice about the name of the type was very awkward. Okay, I probably won't do that. Just example, I just made it up. But if you declare this way, then when you look at the line like I highlighted here, it's very obvious that it is a pointer. It's a data type for pointer to a function, which then you can use the func pointer to do the rest of your code. Okay. All right. Any question? All right, I'm going to switch to the next topic, which is lambda calculus. So we have covered this template. I hope you remember we did this last time. Let me actually go over the slide very quickly. Some of this topic I don't think is, you probably can just run the program to do that. Okay, this is again is this was the program I showed you earlier in the my Emacs window, my terminal, which is combining the concept of template with pointer to function together that you can execute the function, you can assign the value, and then you can do a lot of things. Okay. Okay, so we're done with this function template and pointer. So now I'm going to talk about very quickly to talk about what so-called lambda expression. So lambda expression is a interesting concept that we want to have a function, but this function doesn't have a name. So you will be surprised that sometimes you can have a function, but this function doesn't have a name. And how do we do that? This is called lambda expression is called nameless function, and is useful when you want to pass a function as a argument in the function call. So essentially, you're calling another function, but one of the argument itself is a function. I mean, you can always do that using function pointer, but there is another way to do it. Some people really like to use a lambda expression. So let me give you an example with a lambda expression. So here's an example of a lambda expression. You see that this is a different way of representing a function, almost like a function template as we talk about. But it has, you see that this is auto. I never talk about auto, right? Auto is essentially you're so how do I say that? I declare a variable called IR. And usually the IR is a variable. You declare a variable, you must have a data type for you to actually declare that variable. What kind of data type is this variable? Well, this is not always necessary when you have assignment operator as seen in this example. When you have assignment operator, then on the right-hand side, by the way, IR is on the LHS, which we call left-hand side. And the rest of the code is on the right-hand side, which is the value to be assigned into the left-hand side. And therefore, the compiler can look at your right-hand side, which is starting with this lambda introducer. I'm going to talk about what that is. So the compiler will automatically figure out what's the exact data type of the right-hand side and automatically assign that as the data type for the left-hand side, which is the IR. So in some sense, the right-hand side is, I will now tell you, is a function, it's a nameless function being declared by the lambda expression. And lambda expression declare a function, so therefore it is a function. in fact, is a function pointer. And therefore, IR is a reference to a function. So that's why the data type is going to be a function. And then not only is a function, but it's a function that will return as a Boolean type and input as an argument as a double. Okay, so let's actually take a look at this code first, and then auto is just you just remember is only valid when you have an assignment operator. So compiler can help you to decide the correct data type. Okay, so now let's look at the lambda. The lambda expression started. Let me actually get out of this. Okay, I want to use this one so I can highlight something. So this part is a lambda. From this, what we call a lambda introducer, all the way to the end of the line. So this part I just highlighted is the whole thing is a lambda expression. So lambda expression is a definition about a function, but this function without name. All right. So now let me first before I tell you the lambda's syntax, let me tell you that once you declare this function and you assign to the left-hand side, which is the IR, now IR itself become a function. So I can say IR 35.0 and then print out. Okay, 35.0 become the input. Okay, this function essentially is in range. Okay, I'm using all this code is using this example is in range. So now this is the syntax. Now I want to talk about this part. But then how do I actually syntactically declare a lambda expression? So I'm using the next slide, I believe. So now I can use this one. So I'm actually give you a contrast. The below was the example of the function is in range. You can see that is returning a bool, and then the input argument is a double, and then has a function code. So the first part, the upper part, is using lambda expression to do exactly the same thing. So let me use this one. This is the function, and now I actually section it into different sector. So the first part, I'm actually, you can think about this is the general structure for a lambda expression. The first two is a pair of bracket. And this is what we call lambda introducer. It's just telling people that after whatever I had, after this introducer, the whole thing is a lambda expression. So this is what we call a lambda introducer. And then the lambda introducer, then the first pair of parentheses declare the input argument. Okay, the input argument. Therefore, you can see that this two kind of replace the name of the function, kind of, not exactly. But it doesn't have anything, so you know it's a nameless function, which is a lambda. And then the input argument in this case, this portion is an input argument. That means this function takes one argument and the argument is double. And similarly for this one, this take only one argument, which is the integer I. Okay, that's just input argument. And this part is what I don't like about lambda expression, to be honest with you. I'm kind of old school. So it has this almost like a pointer kind of operator. It's almost like pointer, it says bool. But this is not a pointer. This is basically just declare what should be your return type. So usually in C, we put the return type in front of the function name. But over here, because you want this to be introducer, if you put anything before, I kind of lost my introducer syntax. Therefore, what they did is they use like a pointer operator and not to a particular variable, but to a data type. And that particular data type is a return type. Okay, so this is just the way it declares the return type, meaning that this function is going to return the bool. And then after this, you will see a pair of curly bracket, and within curly bracket is just the way you will write the normal function. Okay, so it's called function body. Okay, so this is a way for you to write a piece of code that you can declare a lambda expression. Essentially, you're declaring a function, except that this function is you can directly use it as an argument. Let me show you how it's being used. So this piece of code that we saw before is basically a function template for doing is and range. Okay, I can define the template and then I define the code. Looks like this. Now I'm going to use a lambda expression. You see that I don't want to use template. Okay, by the way, I'm not saying you should always do this, but sometimes you like to use function template. Some of the people like to use lambda expression. So you can see the way I still declare a pointer func ptr as this particular data type. And then when I assign the value, instead of assign, as you saw here, I assign the value about instantiation from a template like this. What I did alternatively, I just directly put a what I call a lambda expression, which is essentially equivalent to what I did as a template. Okay, and that's how you can assign to that. That's one example. Or you can even combine the template. This is kind of most complicated example. I'm not sure anybody wants to do this in practice, but well, this is a typical academic example in C++ when you combine function template and lambda expression together. So I can declare a template, but within the template, one of my argument is actually a template. It is a lambda expression. So I can have two types. One is T, one is F. And then what I did is that I declare this my lambda and then just basically call the lambda expression. And when I instantiate this particular template, then I will use, you can see that this is I instantiate this this particular function. I actually instantiate as is a range, and then I directly put the what I call the lambda expression as a part of the argument, and then try to do that. Okay, so I can do that, and let me see. Do I have another example over here? Yeah, that's the example. You can combine the function template together with a lambda expression. Okay. Okay, I think I'm done with this part. I hope the last thing I want to tell you is that the lambda introducer, you can put some special configuration between this introducer. If you put an equal, that means when you call this lambda, then all the variable is going to be reassessed, which means that is equivalent to call by value. So you cannot change the value within this function. But if you put the introducer in between the bracket, you put an M sign, that means you have a rewrite access. That means inside you can modify the variable from you access from the outside of the lambda expression. Okay, so this concludes my my introduction to function pointer, function templates, and lambda. Okay. Now I want to go for next. Oh, I have 10 minutes. Okay. So I want to very quickly talk about a concept called class template. Very quickly. 5 minutes. So if you go to CPP 15 on GitHub, there are a bunch of examples about class template. I just want to tell you that this is a linear extension about what you just learned about function template. Instead, you try to have the template to create a bunch of template class. I mean, for example, a lot of STL class, like sorry, not STL, that's right. Standard template library, STL, is essentially created using this simple example. So for example, this is a template. I want to create a class. And this class is a template, but this template is an array. So essentially what I'm doing here is I'm trying to create something which is similar to the STD vector that you have been using. Okay, so it's an array, so it's the same syntax. I just basically say, hey, the template has this the template introducer, and inside the template introducer that you declare what kind of variable parameter you want to provide. I mean, type name T. So essentially, I declare class array private T star T size. So essentially, what I declare here is that now I have an array. That's an array of each of the element is type the type of this array element is the capital T. Whatever you use it, that's the case. And then I declare another variable I have here is a size. And then I declare a constructor, and then I have a way to print this array. So this is a simple, I didn't develop something you can modify or something like that, but you can just, at least you can create the array and you can print the array. Okay, so that's the template for this one. And then, however, I need to also provide a template for the constructor. I have to provide the template for the constructor. Then the constructor is the same thing. I have an array, which is also with a template, which is with an array with the rest of the thing. And then it just basically assign the value of each of the input argument into the array. And then I have to provide another template that's actually for another. But by the way, if you take a look at this, the class declaration has two member function. One is a constructor, the other one is the regular member function. So that's why I need to create template for both of them. So I have a constructor template, I have the template as well. So now I'm trying to run it. And when I run it, you can see that I'm actually creating a template. So it's an array of integer. It's an array of integer. And then inside the constructor, I provide the input argument and the size. And then I print it. Okay, so this is just a very simple example how you can write a template similar to what you do with the vector. Let me just quickly compile it, and then we'll see what it does. Okay, if I run this code, you can see that it's basically printed as we expected. It will construct this this array of integer and then do this. You can use this way, modify to say have an array of JSON or an array of double, an array of any object using the same template. Okay, all right. So yeah, I think I mean, for class template, okay, this is my opinion. Unless you have written a lot of program and you found a common similarity about the data structure, about the classes you define, then you won't bother to create a template. You will just use STL, the standard template library, which is good, like a vector, map. This are what we have done. But one day when you realize you have written so many programs in the near future, and then you realize you really want to create a template, don't worry, just look at the simple example. It's not that hard for you to actually come up with that. Okay, so I'm done with this. So now I want to show you the next class I want to show you is called thread. I'm going to show you a program. Did I put it here? Oh, I have a hello thread. That's great. Okay, typically, when we wrote a C++ program, we're expecting the execution of the program to be sequential. So what do we mean by sequential? Meaning that you call a function, and unless the function is done, then you will not execute the next line. Let me actually give you an example. For example, over here, you see I actually create don't worry about what thread is, okay? I'm going to tell you what thread is later. But over here, I create an object called T1. I create an object called T1. And this T1, in fact, is a function call. It's called a function called task1. Okay, so this slide, you can think about in a simplified way, is you're calling a function which is called task1, and with the input argument called hello. And the second line, I'm actually call the same function, task1, but with a different argument called greet. So essentially, I have one function called task1. By the way, task1 has been defined over here, task1. Okay, so I'm calling a function. By the way, you can use a function pointer in the position of task1. Okay, that's totally okay for you to do that. So I have this two line. I'm actually calling the same function, but with two different input argument. So normally when we roll the line, the code looks like this. We're expecting they are sequentially executed, meaning that you must finish the first line called T1 is completely finished. Then you will execute the second line. So it's a sequential execution. Well, however, in practice, we like to have concurrency. We like to have, if you think about a hardware environment, which I have multiple processor, multiple GPU, or multiple controller on the same board. And therefore, we are expecting we will be able to concurrently execute, for example, NVIDIA or AMD. By the way, it's interesting. Last week, I had a good meeting with AMD showing us their GPU environment, which is quite interesting. So if a GPU, regardless which brand, they have a multiple GPU core, and if I cannot concurrently let the GPU core to execute the same function or different function, then I miss the opportunity to really leverage the performance that I can get from those parallel processing. So therefore, from the programmer perspective, we need to have a way to concurrently execute the program on the hardware that support concurrency. Okay, this is important because the modern system is more and more likely you're using a system that's actually supporting concurrency. Okay, so therefore, I must have a way to declare that now I have two what I call thread, T1 and T2. They both execute the same function. By the way, it's perfectly okay for me to have T1 and T2 execute two different functions. That's not the point. But the point is that T1 and T2 must execute concurrently. T2 doesn't have to wait for T1 to finish. And in order to facilitate such concurrent programming, we introduce a concept called thread. Okay, if I have a time, I will tell you why we will call this threads. I have to give you a little bit more concept about operating system kernel, then I can talk about that in that context. But right now, just remember, thread is an abstraction, is a standardized library that allow me to tell my system about the concurrency about my program. Okay, in order for me to show you the concurrency, you look at what I did. I actually have a task1. I actually print out whatever the message, which is the input argument, but I actually sleep for 10. I sleep for 10. So meaning that you're executing, and then I purposely say, hey, just hang there idle for 10 seconds. So if the program is executed sequentially, then you will see that it must be thread 1 is finished and then go thread 2. But because I do sleep, you will see interleaving between these two threads. That means thread 1 hasn't finished, but thread 2 already started. So that shows how the concurrency is doing. Okay, so I'm going to just show you this program very quickly. So the compiling is very simple. I will call it thread. It's called what? Hello thread. Okay. Okay, I got to compile. You don't need anything. By the way, in order to use thread, just remember to include thread. Okay, you have to add this line, include thread for you to be able to use the standard STD thread. Now I already compile. Now I run TDT. So you see that the hello and greet, they immediately come out. Okay, they haven't finished. Now both threads are sleeping. By the way, for 10 seconds, you wait for 10 seconds, you see they actually come back, both of them. So it's not like a one after the other, but both of them are concurrently being executed. Let me actually repeat this again to show you if I don't use thread, what should be the answer. If I don't use a thread, then what I did is doing this. I'm going to block this, and I'm going to block this. And let me block the rest. And instead, I'm just calling task one, hello. This is sequential. If I do this, task one, greet. This is sequential execution of the same program. I do a compiling. You see, hello, and it will stop. Greet won't start until it finish. You have to wait for 10 seconds. Now you see, hello is done. Now greet start. So this is non-interleaving. You see that this two output, they're actually hello and greet are mixed together. But this one, hello and greet are done one by one. Unless hello finish, greet won't have the chance to start. Okay, and this is exactly a simple beginning for us to do GPU programming. Essentially, GPU programming, you have to use thread. And you have to assign each of the thread to each of the core in your hardware environment in order to do the job in parallel concurrently. Okay, I will talk to you on Thursday about the GPU programming, but you will see a sign up sheet for, and you can just come over here for tomorrow evening. Okay.
配壳哦，那个主要是要有那个比例的，不然要怎么练？